So welcome to my YouTube channel. So today we solve the problem of not attacking black and white knights, which means not collapse white and black. The problem says that given two indices and an M representing the dimensions of chessboard, find the number of ways to place one black knight and one white knight on the chessboard such that they cannot attack each other. The knights have to be placed on different place, right? A knight can move two squares horizontal and one square vertical, that means L shaped, or the squares vertical and one square horizontal, L shaped. The knight attack each other if one can reach the other in one move, right? So the input is n is equal to 2, m is equal to 2, and the output is 12. Correct? Now I just explain the problems, then you will definitely understand what I am saying and what the problem says. Like, we have a chessboard of size n into m, correct, and placed here one black knight and one white knight. They must be on different cell, that's correct. Yes. Now the count arrangement where they cannot attack each other, the count arrangement where they cannot attack each other, since knight have different color swapping positions is different, which means I just write if black at A and white at B, correct, is not equal to, we can write this, and black at B and white at A, right? So the orders matter, right? So there is the orders matter. Now I just consider the n is equal to 2 and m is equal to 2, right? Now what we can do, the board is make like star and star and star and star, correct. Now total cell is 4, that's totally correct. Now choose positions for black, right? Now choose positions 4 ways. For black, for black position is equal to 4 and white position is equal to 3. Now 4 into 3 is equal to 12. So that's the reason there is a 12 answer, right? Now the same type, if we consider this one, then n is equal to 2 and m is equal to 3, which means 2 by 3 ka pair, which means 6 cells, and the 6 cells is equal to 6 into 5 is equal to 30, right? 30, which means, and the 13, which means if there is a 13, so there are the 26 ways to it, that means 63. तो इसमें क्या होता है, सबसे पहले 2 attacking pairs, right? So we just have to attacking pair to reduce it. That means, like, if we have the one knight attack with 2-1 and 1-2 attacking, that means if we have to attacking, then on the same board 2 into 3 boards there are exactly 2 attacking pairs, which means 2 into 2 is equal to 4. So 30 minus 4 is equal to 26. So that's the reason there is a 26 the answer. So what is the key observations? The key observations is n into m, n into m into n into m minus 1, right? That is the reason, and that's the point. Now I just write the code and explain you the whole concept. The code is very, that means inoptimal, very less line of code. You will definitely understand what the code and what the problem says. So we have the int and m, we just have to take the long, right, long cells is equal to 1 ll means long into n into m, Now long long total placements is equal to cells into cells minus 1, right? Now long attacking placement is equal to 4 ll into 1 ll, right? This is the 1 ll, and then we just have to put the our uh, that means concept, which is n minus 1 into max of into max of into max of 0 to m minus 2, right? And there is plus, as a plus 1 ll into n minus 2 into max of 0 to m minus 1, right? This one. Now the return is total placement minus total placement divided by sorry, this one. Now just run yes and try to submit it. Yes. So in that, if we not write this one ll, then that is the very smooth, and that is very understanding. So that is, I just take for the edge cases, like if the use number, then I just take for it for 1 ll, right? That means long. So in that, the time complexity is order of 1 and space is also order of 1. So that is the very efficient problem, and that is a very efficient solution. So make sure you are very understand this problem, and make sure you have the another approach, then please write on the comment sections. I really appreciate this. Thank you so much, guys.